Light and day is more than you'll say, 'cause all my feelings are more than I can let by or not, more than you've got. Just follow the day, follow the day and reach for the sun. You don't see me fly to the red one more, you're done. Just follow the seasons and find the tide. Reach for the bright side. You don't see me fly to the red one more, you're nuts. Just follow the day, follow the day and reach for the sun. Just follow the day, follow the day and reach for the sun. You don't see me fly to the red one more, you're nuts. Just follow the seasons and find the time. Reach for the bright side. You don't see me fly to the red one more, you're nuts. Just follow the day, follow the day and reach for the sun. Just follow the day, follow the day and reach for the sun. Just follow the day, follow the day and reach for the sun.
All right, so today we're going to be starting on our next topic, our next module, which is loops. Loops are a way for you to execute a chunk of code or a line of code repeatedly over and over again until some condition is satisfied, or until some other condition is no longer satisfied. Basically, you don't want, if you have a lot of data, for example, 100 pieces of data, you don't want to cut and paste code 100 times and apply that to each one of those pieces, because first of all, you don't cut and paste code. That's a bad strategy. But also, you don't know that you're going to always have exactly 100 pieces of data. Sometimes, in fact, when you're writing the program or before you even compile it, you don't know exactly how many pieces of data you have. Sometimes you'll have 10, sometimes you'll have a billion, right? So you need to be able to apply a piece of code over and over again, iteratively, to that that collection of data. With a loop, that's how you do it. You need a place to start, you need something to do, and then you need to know when to end it. And those are the four basic elements of a loop control structure. We have to have somewhere to start, because I always give the analogy of running around a bunch of laps. If you're going to do 10 laps around the track, well, you've got to start somewhere. You got to start running. And so that's an initialization statement, where the loop starts. A continuation condition is where that tells you to keep going. If I'm going to run 10 laps, but I've only run 3 so far, and I get down to now this is the 3rd lap, okay, now I need to keep going. All right, 4th lap, 5th lap, etc., until I get to the 10th lap. Only after I've gotten 10 laps do I stop. The opposite of that is the termination condition. The continuation condition says, yes, run 1 more lap. The termination condition says, no, you've run enough laps, go ahead and stop. Right? These are just the inverses of each other, or the negations of each other. You also need to be doing something to make progress towards that termination condition. If you don't make progress towards that termination condition, you're going to just keep running around until you fall down dead, right? So what you need to do is you have to an update or an increment statement that says, I've run 1 lap, I've run 2 laps, I've run 3 laps, so that you keep track of how many laps you've run so that you don't keep going on and on forever. And then finally, you do something in the loop body, right? You don't just write code that does nothing once, does nothing twice, does nothing 3 times, right? You actually have to be doing something inside of the loop body that executes for every iteration of that loop. To get started, we're just going to go ahead and start with what's called a for loop. And guess why it's called a for loop? Because it uses the keyword for, right? All 3 of the main elements, that is the initialization, continuation, and increment, are on the same line. In C, you would write it as follows. So I'm just going to go ahead and go with a very simple loop that just prints out numbers 0. Well, here, we'll understand it here in a second. For int I equals 1, I is less than or equal to 10, I plus plus. Right? Printf, I is equal to %d and the line, and then we'll print out the value of I in this piece of code here. Okay. So the initialization condition is right here, or the initialization statement. Where am I starting? I'm starting at the first lap, lap number 1. Right. So I is 1. This is the continuation condition. I don't stop until I've run 10 laps around the track. Right. As long as I is less than or equal to 10, we're going to continue doing this loop once more. The second that it is beyond 10, 11, 12, whatever, right, then we're no longer going to execute this loop and we break out of it. Here is the increment condition, and this is new syntax. We'll study this in a little bit more detail in a moment, but for now, just understand that that adds 1 to I. So if I is 1, then it adds 1, and now it's 2. Now it's 3, now it's 4. And all it's doing throughout this entire process is printing the value of I. Right? So let's bring this over to a new tool that you can use if you want to. It's the URL here is pythontutor.com, but then you can go to a C version of it, and you can visualize your code execution here. Right? Let's go ahead and visualize this. It allows you to not only visualize and look at things, but it allows you to step through step by step. So I'm going to go ahead and start at line 5. You'll see over here that I has been created. Okay. And what's its value initially? Until I hit that initialization statement, it's a question mark. Remember, dead beef, right? Undefined. There are no default values when you create a variable. But the very first time that I go through this loop, I set it equal to 1, and we'll see it take on the value of 1. Now it checks to see if I is less than or equal to 10. Is it? Yep. So therefore, what are we going to do? We're going to go into the loop, print I is equal to 10, is equal to 1. Right? Now what happens at the end of that loop is that I is going to increment, I plus plus. You'll see it over here. I gets automatically incremented to 2. It makes the check. Is 2 less than or equal to 10? Yep. So print out 2. 3, 4, 5, 6, 7, 8, 9. There we go. 9. All right. And it's going to increment to 10. Now, is 10 less than or equal to 10? Yeah, because it's equal, and so it prints out 10. Now, what's going to happen after that? It's going to come back up and increment it to 11. We didn't see that because it doesn't show it. It breaks out of this for loop and continues with normal linear control flow. So in this case, we're printing out 1 up to and including 10 by 1s. Right? So let's note some syntax here, or the behavior here. The initialization statement, I is equal to 1, I starts at the value 1. The continuation condition checks, that is, I is less than or equal to 10, is checked at the start of each iteration of the loop, right? If it is true, the loop body executes, right? If it is false, we break out of the loop and continue with normal linear control flow, top to bottom, left to right. Okay. The another thing I should say here is that the initialization statement is only ever executed once at before the loop starts. So we're not going to be setting I equal to 1 over and over and over again. The increment is executed at the end of the loop, right? And in this case, it's I plus 1. So this is the new syntax. Right? I plus plus is shorthand for I is equal to I plus 1. Right? I'm not going to say that it's equivalent because it's not. It's the second one there is 2 operations. The I plus plus is 1 operation, right? You can also use plus plus I. Oops, plus plus I. There we go. This is the prefix version, right? But I'm not going to. You're not going to see me using that because there is a difference between the two on what value the expression has after it's done. Is it going to be the original value? Like if I've got 5 and it goes plus plus, is the value going to be 5 or is it going to be 6? Yes, we're adding 1 to the variable, but if it's using an expression, then what value does it take on? And there is a subtle difference there that I'm going to entirely skip because I'm going to discourage you from using those in expressions. So don't worry about the prefix version. I will only ever use the postfix version, which is to go I plus plus. Okay, I would encourage you to just stick with this for now. Maybe later on, if you want to experiment and play around with plus plus I, go ahead. Well, if you can add 1 to it, then you can also subtract 1 from it. Right? Decrements I by 1. Right, 1. Right, it's equivalent. It's not equivalent to, but it is shorthand for I is equal to I minus 1. Okay. So this is nice syntactic sugar because you're going to be doing this a lot. All right? It's a common operation to add 1 or subtract 1 or all over the place. And so what you can do is you can shorthand it by just going I plus plus, I minus minus. There's also others, right, which include the compound assignment operators. Right? For example, you can go up by increments of 2 instead. It is shorthand for I is equal to I plus 2, right? I plus equals 2, and you read that left to right. It's not going to be equals plus, it's plus equals. And that's shorthand for just adding 2 to it. Because sometimes the plus plus and the minus minus, that only ever works with 1. If you want to go up by 2's, you can use this syntax instead. If you want to go down by 2's, you can do that as well. I minus equals 2 is shorthand for I minus, or is equal to I minus 2. Right, there we go. And you can go beyond plus and minus, and you can use multiplication and division. If I were to write I times equals 2, what do you think that that's shorthand for? I is equal to I times 2. In other words, it doubles the value. Right? And finally, let's go with I divide equals 2 is shorthand for I is equal to I divided by 2. Careful with truncation. Right? Because what if I was 7? 7 divided by 2 is 3.5, but we can't have that as an integer result, so it would end up being just 3. Okay? Those are nice little shorthands, and it doesn't matter if you use 2. You could use 3, you could use 5, you could use an entire expression. Right? I'm just showing you that it doesn't have to be 1 all the time. Okay? All right, let's go ahead and play around with this, and let me bring this loop. Let's edit this code here. And let's bring this loop over here and start playing around with it a little bit more. I'm going to go ahead and get rid of everything that we were working with on Monday and start over. There we go. And, okay. There we go. There, that's all indented nicely now. All right, let's go ahead and change some of these values. If I went from 0 but strictly less than 10, what values is it going to what values is it going to output now? So what's the first value that it's going to output? 0, because you start at 0. But what's the last value that it's going to output? 9, because it's strictly less than 10. Okay? Let's go ahead and execute this and see why, or see if we're correct. 0 through 9. Good. Now again, why did that happen? Well, at some point I is 9, right? We print out 9. Then we come back up to the top of the loop. 9 becomes 10. Is 10 strictly less than 10? Nope. It's less than or equal to, but it's no longer strictly less than 10. Okay? So, what if I went up by different factors? Plus equals to. Using that new syntax now. Now I'm going up by 2's. Let's go ahead and clear this out. And recompile it and run it. Again, predict what is it going to run here? What's the first one? 0. And if it's going up by 2's, it's going to go 2, 4, 6, 8. That stopped. Good. 2, 4, 6, 8. There we go. So you have to know where you're starting. You have to know where you're ending, right, by taking the opposite of that. And then you need to know how you're going to get there, the increment on those. Let's make some other observations about this syntax. Right? Let me go ahead and move it up. Yeah, right there. So we use the keyword for, of course. Then all 3 of these things are inside parentheses. Like I said, they're all on the same line. But look at the semicolons. Right? So after the initialization condition, what do you have? A semicolon. After the continuation condition, what do you have? A semicolon. But do you have a semicolon on the increment there? No. Weird syntax, right? So the semicolons are at the end of the initialization and continuation, but statements, but not the increment statement. Increment statement. Weird syntax, but yes, that's how it's done. Don't ask me why they did it that way. I think that's because they were feeling that, well, we've got 3 things here and we only need 2 delimiters to separate 3 things, right? We just need 2 things in between. And so they said, all right, let's go ahead and use semicolons here, right? This one makes sense, right? Because it's an executable statement. If you were to do this outside the loop, int I is equal to 1, then you would have a semicolon. This one doesn't make any sense. Do you remember with the if statement, we did not put a semicolon at the end of it, right? Instead, we had a body, right? But this is not an executable statement. It's a true or false statement, but we still have a semicolon on it. This is an executable statement. It does something. It adds 1 to I, but it doesn't have a semicolon on it. Don't ask me why. It is what it is. Let me show you that, again, it will not compile if you do it any other way. There we go, right? You can't put a semicolon there. Forgetting about a semicolon there will definitely be a syntax error as well. Okay? So restore. And what I'm going to do is I'm going to put this into what's called an idiomatic for loop. Eventually, you're going to have arrays that are going to have n elements in it. Let's just go ahead and say that there are 10 elements in there, right? Eventually. And you're going to be writing loops like this all the time to iterate over those elements in the array. This does not have to be a hard-coded value, a literal 10. Instead, what I can do is I can put the variable in there. And then if I want to go from 0 up to 9, this is going to be 10. If I want to go from 0 up to 99, I can do that as well, right? Or I can go up 0 up to 999, right? And I didn't have to change my loop down here because it all relies on that one variable right there. Okay. All right, let's kick that back down to 10. All right. Any questions about this so far? All right, then Zybooks, I forget how they do it, but they might do it a little bit different. They might show you something that looks like this instead. Int I is equal to, or I is equal to 0, right? This is basically going to be the same thing. This is going to still print out 0 through 9. Watch. Come on, there we go. There. Come on. There we go. 0 through 9, okay? But what's happened here is that I've increased the scope of I. Do you remember the scope, right? That's where a variable is born, it lives, and then it dies. It exists. You can only see this variable by looking through the submarine telescope, or not telescope, but periscope, that's what it is, right? You're only looking through a scope. You can only see that variable I. Now before, when it was declared like this, that variable no longer exists after the for loop. Let me prove it to you. Let me go ahead and try to print out the variable value after this loop. How did we break out of this loop? I became 10, and it was no longer strictly less than 10. And so we broke out of this loop. Will I be able to print that value? Let's find out. Nope. Undeclared identifier on line 17. The problem is that I was declared on line 14. It lived throughout this entire loop, but then it died on line 16. It went out of scope and was no longer available. Consequently, I can't print it down here. But if I had declared it outside the loop and then initialized it in the loop, now it will compile. Because it was born on line 14, it exists throughout line 15 through 17 just as before, but it still exists on line 18 here. What value does it finally have? Final value. So predict. This, of course, is going to output 0 through 9, just like before, but what will this end up printing? What value of I got us out of that loop? 10. Come on. There we go. Right. Final value is 10. Right? Because again, what happens? Well, it's 9, so we print it out. We come back up to the top of this loop. Is 9 less than 10? Strictly less than 10? Yep. So increment this, or sorry, at the end of the loop, we increment it. 9 becomes 10. Come back up here. Still a 10 in my hands here. 10 is not less than, strictly less than 10. And so we break out of the loop, but what values does I still retain? 10. Let's take a look at that in the Python, the visualization tool over here. The URL is Python Tutor because it was originally for Python, but they support many different languages here. There. Visualize this execution. All right. So initially, n and I have not been set. N gets set to 10. I is still not set because we do not have a default value here on line 6. And so on line 7, we set it initially to 0. We go through that entire process, printing 0 through 9. Not too far up. There we go. You see that it was incremented to 10, and that's why we broke out of the loop. 10 is not strictly less than 10. We jump down here to the final value, retaining that value of 10 right there. Right? In general, you don't want to do that, though. Right? You don't. In general, you should limit the scope of variables as much as possible to avoid unintended consequences or side effects. Right. Don't just declare one variable I and then you reuse it and use it over and over and over again if you've got multiple loops. Right? By the way, why do we use I? We use I for, well, it's an increment variable. For increment, or index. When we get to arrays, we'll start calling them indices instead. And so that's why we use I. Right? It doesn't really stand for anything. You could use X, but it'd be kind of weird because it's usual to use I. Right? You could use A, you could use my awesome variable, whatever. But again, you have to have descriptive variable names. But in this case, what does it stand for? It's just a counter variable. It's I. Okay? All right. Any questions on for loops? You'll do some coding kata in your lab next week when you get there. Write a for loop to print out the values 3 to 100 by increments of 3, or stuff like that. Just getting practice setting these 3 different things: the initialization, where you start, the continuation, and how you make progress towards that termination condition. What we're going to look at is another type of loop, a while loop. Right? While loops use the keyword while. Who would have guessed? Right? The main difference here is that the 3 elements, that is the initialization, the continuation, and the increment, are all on different lines. Okay? So I'm just going to go ahead and jump into it here with a code sample. We'll have the initialization condition here. Right? Int I is equal to 0. We'll go 0 to 9, right? Let's go n is 10, right? While I is less than n, there's my loop body. So I've got the initialization condition before the loop. My continuation condition is inside parentheses next to the while statement. And then I'm going to go ahead and have my print statement here. No need to retype that. I'm just going to steal it from up here. There we go. Now, where do I put that I++? Well, if you want it to happen at the end of the loop, you can put it right there. That's an equivalent loop. Let's go ahead and grab this code and run it just in our CS50 IDE over here and see that it, in fact, does the exact same thing that we were just doing before. Right? GCC, out, there we go. 0 through 9, right? So why would you write it like this? Well, you can play around with it and it's a little bit more flexible. Right? But first, let's make some observations. The initialization occurs before the loop. Right? The continuation is bound within parentheses on the while loop. Right? So these parentheses right after the while loop here. If you don't have parentheses, it will be a syntax error. For example, if I just have this and this, that's not going to work, right? I don't know what you're talking about. You have to help the compiler by putting parentheses around it, right? Besides, it looks kind of ugly, right? Without that. It looks wrong, at least, once you get used to it. And then the loop body has, of course, opening and closing curly brackets. And in this case, the continuation condition is done at the end, or the increment is done at the end. The increment in this example is placed at the end, but it doesn't have to be. Right? You can put it wherever you want. With a for loop, that increment statement, that's going to happen at the end of the loop no matter what. You can't change that. What if I changed it over here in the while loop, though? What if I moved it to being the first thing that I did? Okay? Now let's walk through this before we look at, Python Tutor, or before we actually even compile it. So 0. I is 0 right now. Okay? Is 0 less than 10? Yep. So we execute this loop. Before I print it out, what was the first thing that I do? Increment it. So what's the first thing that gets printed now? 1. Come back up here. Is 1 still less than 10? Yep. Increment it. So the next thing that gets printed is 2, ... At some point, it's 9. Right? 9 is less than n. We come into this loop and we increment it to 10. It gets printed out. So what's the last thing that gets printed? 10. Run it. There we go. 1 through 10. You can place this anywhere that you want. You can place it at the beginning of the loop. If I've got multiple things, like printed it out, and I can put it in the middle of the loop. I can put it at the end of the loop if you've got multiple lines there. Okay? Let's go ahead and restore it. Oops. I forgot to put it back in. What's going to happen? Not a syntax error, not even a warning. Let's walk through it. I is 0. Is 0 less than 10? Yep, print it out. Go back up to the top. Is 0 less than 10? Yep, print it out. Go back up to the top. Is 0 less than 10? Is 0 less than 10? Is 0 less than 10? I am not making any progress towards my terminating condition. What do you think will happen? Yep. 0, it just continues on forever. That's an infinite loop. Okay? It will continue until I kill it. And you will eventually write code that you'll get stuck in an infinite loop like this. You eventually will need to kill it so that you can go back and fix your errors. To kill it, you go Control C, right? And that kills the current running program. Okay. The infinite loop was because I did not have my increment I++, right? So this one will work because it's making progress towards that terminating condition. Before it was just 0, don't do anything to it. 0, don't do anything to it. 0, don't do anything to it. But now it's 0, 1, 2, 3, 4. And eventually I get down up to this. Right? Yeah, if you wanted to change this, what if we went up by 2's? Now it's going to be 0, 2, 4, 6, 8. Right? What if I wanted to go up by 3's? What would it be? 0, 3, 6, 9. There we go. Etc. If you wanted to go multiples of 3, that's a good question. Predict now what will happen. 0. 0 times 3 is? 0. 0 times 3 is? 0. 0 times 3 is? 0. So we're in another infinite loop here. I'm making progress towards the terminating condition. No, I'm not. All right, just kill it. Control C. If I had done this correctly by starting at 1, now 1 times 3? 3. 3 times 3? 9. 9 times 3? 27. So that goes beyond the loop already. So what will that end up printing? 1, 3, 9. Yep. And 27 is not less than 10, so it breaks out of that. Okay? All right. So it doesn't have to be, right? You can place the increment statement in anywhere in the loop, right? Failure to have a correct increment statement may lead to an infinite loop where it just keeps going around and around and around, right? To kill the program, use Control C so that you don't get into that situation. I mean, you will get into that situation. Everybody writes code either intentionally or unintentionally that gets into an infinite loop, and you eventually have to kill it. Okay? All right, so why did I just show you 2 loops? Right? Why do we need 2 loops? Right? So my first observation is that any while loop can be rewritten as a for loop, and vice versa. You can take any for loop and rewrite it as a while loop. So why do we need 2 loops? Well, because we like having options. It makes languages more flexible and usable and readable. Right? Imagine the English language. If I only allowed you one adjective to denote good, right? Good, great, nice, right? Whatever other adjectives, awesome, cool, right? Or whatever other adjectives you can come up with that mean a good thing, right? We have hundreds of those words. Imagine that we only had one. It wouldn't be a very expressive language. It wouldn't be very flexible. It wouldn't have any of the nuance, right? But there's also a more usability reason here, right? Generally, for loops are used when you know how many iterations you are going to execute. While loops are used when you don't know how many iterations you are going to execute. Right? So, for example, that for loop that we started out with, it simply went from 1 to 10. I knew exactly up front how many iterations I was going to do, 10. So a for loop was very appropriate to use there. Let me give you another example, and we'll go over here completely into the CS50 IDE here. And let me go ahead and have a variable here x, 1, 2, 3, 4, 5. Right? Now, if I were to ask you how many digits are in x, as a human, you can look at this and see that I just wrote down 1, 2, 3, 4, 5. How many digits are in it? 5. A computer can't do that because a computer can't look at something and just answer a question like that. Okay? And I've even seen people use donked up versions of ChatGPT, even asking similar questions, and it can't get it right. Right? How many digits are in this? Usually it'll probably get it right, but how many digits are in X? 5. Well, if I changed it so that it was just 3 digits, now it's 3. Right? What if I didn't give that up front? What if I read that input as from the user? In other words, a to I of argv sub 1. Remember command line arguments. The first one provided by the user will be an integer. Right? In this case, we want to read in an integer. Right? So let's go ahead and print this out to make sure that we get it. Printf x is equal to %d end the line, and we'll print out x here. GCC. If I just go ahead and give it 1, 2, 3, then it'll be 1, 2, 3 on that run. But if I gave it 1, 2, 3, 4, 5, it'll be a completely different input. How does the computer know how many iterations it's going to go to be able to count this up? Well, if it knew how many iterations it is to compute this thing, int x is equal to 1, 2, 3, 4, then you'd already have your answer. Right? Okay? So, chicken and the egg. Let's figure out how to tell a dumb computer how to figure this out. Okay? All right. The answer I want is 5. How do I go about getting that? We'll restore this here in a second. Right? Ideas. This is called the whiteboarding phase of problem solving. Right? You put a bunch of stuff up on the whiteboard, but I'm not using a whiteboard here. You try to figure it out on one example, like 1, 2, 3, 4, 5. Figure out how you might approach that problem. And then once you've got an example worked out on a piece of paper or on a whiteboard or something, then you start coding and say, how can I translate that process into code? So give me ideas. Give me whiteboard ideas here. How could I figure out that there are 5 digits in this number? Count them, okay. So normally if you were a human, you'd start from the left, right? And you go, okay, there's 1, there's 2, there's 3, there's 4, there's 5. Right? Computer can't do that though. Right? At least there's no command to do it. Here's a hint. What if I worked from the other end? Right? What if I were to move that decimal place over there? Right? What operation was that? Division by 10. Right? You're just dividing it by 10. Right? So if I were to divide by 10 to give you this, well, remember integers. What if I were to divide x by 10? What actually happens to that 0.5? Truncation throws it away. Do it again. How many times have I done that so far? 1. I'm going to keep my finger up here and count the number of times that I divided by 10. There's another division by 10. But what happens to that 0.4? Goes away. Another division by 10. Right? That 0.3 goes away. Division by 10. Division by 10. What happens when you divide 1 by 10? You get 0.1. What's the result in the end? 0. How many times did I do that? 5. There's my answer. Right? So if we divide by 10 until ... what condition should break us out of this operation? When did we stop up here? When it was 0, right? 4, 5. Until x is 0. Right? Keep a counter as you go along to count the number of digits. Right? Okay. A for loop? For int I equals 0, I is less than n. That kind of tells me that you already have the answer, n, the number of digits, right? That's why it's probably not the most natural way of doing it. So what if instead I did a while loop? Right? There's our shell, first of all. I need the initialization condition, the continuation condition, and the increment condition. Okay? Where do I start? I've got my x up there. That's done. That's given as part of the input. All right, maybe we'll come back to that. At least what's my continuation condition? Divide by 10 until x does not x. So I continue dividing by 10 if x is not 0. So while x is not 0, divide by 10. Right? Just reading that back and forth there. And what I'll do is I'll say x is equal to x divided by 10. Hey, have we learned something new today that we could go ahead and shorthand that? What? Divide equals? Okay. Keep a counter as you go along. So maybe num digits. Number of digits plus plus. Or is equal to plus, num digits plus 1. Again, what's the shorthand for that? Plus plus. All right? So, come back up here and I'll ask the question again. What should be my initialization condition? First of all, do I have a num digits variable here at all? Nope. So let's create it. Int num digits. Where should I start it? Actually, if I don't start it, what value does it have? That question mark, that dead beef. Maybe it's 0, right? 99 times out of 100 it'll be a 0. But as I've witnessed to several folks using Windows and using like they downloaded VS Code and they're using Windows instead of the CS50 IDE, they're getting weird results because Windows does weird things, right? They're getting like 32,000 something for a default value. Right? So there is no default value defined. What should be the default value? 0. Why? Because how many digits have you counted so far on line 20? None. So 0. Right? Let's go ahead and print this out now. Printf. X has %d and line digits, or digits. And line num digits. Okay. All right. I'm not going to give a command line argument because what I've done is I've hard coded it to 1, 2, 3, 4, 5. Do we get our answer? What's the expected answer, by the way? 5. That's a test case. We've got an input. We've got an expected answer, 5, sitting here on my hand. Does our output match the expected output? Yeah, it has 5 digits. Yay. Now let's go ahead and restore that command line argument so that we can test other things without having to compile, recompile every single time. Right? A.out, 1, 2, 3, 4, 5. We should still get 5 digits. 6? 6 digits. 7? 7 digits. Maybe it doesn't. Maybe it only works for 1, 2, 3, 4 kind of numbers. What if it went for 4, 4, 4, 4, 4? 4 fours. I should get 4. What if I just had a single digit? 9. Right? Should I test anything else? Negatives. All right. Negative 1, 2, 3. How many digits does that have? 3. Okay. Oh, that works. 4, 5, 6. There we go. Those all work. What else should I test? No digits. So what's that? Oh, I guess we could go characters. Hello. Right. That'll end up being 0. And 0 has 0 digits. This is the one I wanted to do. 0. Same thing here. Is that right? No. This is what we call a corner case or an edge case. Sometimes things blow up at 0, as you've seen in, say, if you've taken a calc class. 1 divided by x. Is that defined at 0? No, but it's a nice it's a nice graph, except what happens at 0, it blows up this way and it blows up down to negative infinity over there. That's one of those edge cases that you have to take care of separately. Right? So how should we take care of that? By checking that one edge case. If x is 0, then we'll give them a different message. Printf, 0 has 1 digit. There we go. End the line. And then we can exit the program. Exit normally. Or we can go ahead and wrap everything else around in a big else statement. There. Couple of options there. GCC this, and now I get the correct answer. 0 has 1 digit. Make sure that you didn't regress. Go back and check and test everything. This is why we had you write some actual informal test cases in your lab yesterday to test the leap year function, right? I don't want to have to go through and try everything. Oh, but we forgot about negatives. Does that work? Okay, that still works, right? All this manual process. You code to test other code so that all you have to do is push one button and it does everything for you, right? We'll get into more formal unit testing later on, though. Right? All right, I'm pretty convinced that that works. But again, would it have worked for a for loop? Help me translate this into a for loop. For int num digits is equal to 0, while num digits is less than the actual number of digits. Num digits plus plus. That kind of tells me what? That you know how many digits there are to begin with in order to write this for loop. Yes, you can write an equivalent for loop for this, but I'm not going to show it to you because it would look weird. But I'm just trying to drive home the fact that some situations it's more natural to use a for loop, and other situations it's more formal to use a while loop. Right? But you should know both of them. Also, there are also do while loops. There are also do while loops that execute that loops that have their continuation condition checked at the end of the loop instead, right? And you probably will see those in your Zybooks readings, but I'll omit them. Omitted. Right? They are brittle and kind of useless. Right? You just rewrite your logic so that you can use a regular old while loop. Okay. Right. Other languages have other types of loops. For each loops, or parallelized loops. Right. And parallelized loops, you'll get exposure and practice to that in your PDC modules. Reminder that the PDC essay, or not essays, you're not writing an essay. The PDC surveys are due this Friday by midnight. So make sure that you're doing those. We are grading based on completion. We don't care how much you know about parallel and distributed computing. We're assuming that you don't know anything about it. So go ahead and answer all those questions with, with full honesty, because it doesn't matter if you get it right or wrong. It's part of the study that after you go through those modules, you will know something about parallel and distributed computing. Right? But you do have to go through the surveys, the two surveys, A and B, by Friday, right? And you'll get full points just for completing them. Okay. All right. So with our few minutes left here, let's take a look at some more pitfalls, just like we did for conditionals. Take a look at that code and tell me, do you see something wrong there? I'm going with the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my intention there, to print out 1 through 10. Do you see something dangling there that shouldn't be?
The semicolon after while.
Yeah, the semicolon after while. You're as good as the compiler, right? The compiler can check this if you tell it to. Let me go ahead and make it nice. Clear this out. GCC demo.c. Right. If you just do it straight up, it's not going to catch the error that we just had. What's that thing that we looked at before that will catch this kind of stuff? The wall flag. Right? Hey, wait a second. Warning. The while clause does not guard. There's something wrong there, right? Are you sure that there's something wrong around this area right here? And that thing that's wrong is this superfluous semicolon, right? It still compiles. It will still run, but let's predict what's going to happen here. I is 1. While I is less than or equal to 10, do something. What is that something? That something is nothing, right? Here's what it really means. While I is less than or equal to 10, do nothing. Right? And so it will do nothing. It'll just sit there and spin. Right? It's not even printing anything out because the printing is not bound to this while loop. It's doing nothing on line 15 right now. Right? So again, how do we kill it? Control C. Right? Undo, 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 undo. There we go. And there, that'll fix it. Again, the wall flag will catch that. The semicolon is misplaced and the loop body results in a infinite loop. Control C kills it, right? And use the proper wall flag. Oops, sorry, hyphen wall flag every time, and it will catch this kind of stuff. Right. One last one. We won't answer the question, but go ahead and take a look at it for next time. Do you see something wrong there? We already did it anyway. I gave a preview of it already. Yeah, what am I? I've got, there are 4 components, the 3 main components. Initialization, continuation. What's the third one that I'm missing? Increment. So again, what's going to happen here? 0, 0, 0, 0, 0, 0, 0, infinite times. Right? We'll look at some more pitfalls on Friday.